Hi, welcome to Engineering, and today I'm going to explain the joins and polars. Now please take note that joins and polars are very important calculations, especially when we start doing more complicated calculations considering coordinates, angles and directions. Now I just want to highlight that this will be more important in the southern hemisphere, specifically where South Africa will be, so some values might differ in other countries. Alright, so the first one we're going to do is the join. Now the join is basically the calculation that determines what joins two coordinates. So the two values that do link or do join two coordinates will be the distance and direction. Alright, and in this term, in these equations, direction is your horizontal direction. So we're going to work with this example BE, where we're trying to determine what's the direction from B to E and what is the distance between the two of them. Please note, if you want to have direction E to B, you should put E with its coordinates first. Now, the first thing we do is we write the Y coordinate and the X coordinate on either side for each of the two coordinates, or the 2 points. The next step will be to say the bottom coordinate, so the bottom Y coordinate minus the top Y coordinate to give us our delta Y, or the difference in Y. We do the same for the second one. We say the bottom one minus the top one gives us our delta X. So this is our difference in X values. Now these values are very important because it helps us calculate our distances and our directions. Now the first thing we need to do is we have to calculate distance by saying the square root of delta y squared, which is this value over here, plus delta x squared, which is this value over here. When you put the two values into the equation, you'll get an answer, and that answer will be in meters, which is our distance. Now please take note, I put in all the decimals here just to make sure, but usually you'll only put up to about 3 decimals. For the direction, we do the next step of saying arctan of delta y over delta x. So this delta y value over the delta x value. Now we don't know where this value is or in what quadrant we are, so to cater for that different quadrants, the 4 different quadrants, we have to consider our x and y delta values, or the differences. So the first thing we do, and this is just a summarized version just to make it easier for ourselves, a full explanation can also be looked up. But if delta x is positive, then we look at y. So this is our delta x value. In this case, it is positive, so we'll go straight to look at y. However, if it was negative, we'd say if delta x is negative, then it's that value. So this one we calculated here, plus 180. But since it is positive, we're going to look at y. Now our y is negative, so it says y is negative, so then we say that it's our value plus 360, which gives us this answer. And that is the proper direction from B to E. We write down over here. Now every join needs to be tested with a polar, since a polar is the opposite calculation to a join. So what I'm going to do is I'm going to explain how we're going to do this polar. Now, a polar requires one set of coordinates as well as a distance and direction to determine another coordinate. So what we do is we take the distance and direction, which we just calculated. You'll see it's slightly, I have slightly rounded it off here. We'll take these values and we'll put it into equation with the first coordinate, which we used at the beginning. So this is just testing ourselves to see if we actually got the right answers. Now what we do is we will use the formula of distance times sine of direction, or distance times cos of direction for delta y and delta x respectively. Now what we'll do is we'll say it's the same values here, the only difference is there's a sine or a cos for the y and for the x. So we determine these values, and you'll see that these values are very similar to the original values for delta y and delta x that we calculated. Now because I rounded off the value, sometimes this might differ by a few decimals. Now since we have the coordinates and our delta y and delta x, we can easily calculate our other coordinates. So the way we do that is to say a y coordinate plus our delta y gives us our e's y coordinate. And we say the x coordinate for B plus delta x gives us the x coordinate for E. Now because these two values are very similar to the original values, or exactly the same as the original values, we can confirm that we've tested our values and that these values, the distance and direction, are correct. Now just to give you another example, we're going to start with a polar, where you are only given a distance and direction and coordinate that you will use to calculate another coordinate. So in this case, we're going to be trying to work out the coordinate for h, because we have a distance from G to H and a direction from G to H. So the first thing we do is we calculate our deltas by saying distance times sine of direction for delta y and distance times cos of direction for delta x. So it's the same method as we did in the previous example. Then we take those two values, we say the coordinate plus the delta y gives us a y coordinate for h. The same with this one, we say our x coordinate plus delta x gives us our x coordinate for h. So now we're going to do the opposite of what we did last time, and we are going to take the g coordinate, or set of coordinates in the beginning, with h's coordinates that we have calculated to calculate the distance and direction between the two. And this is for our test join. So then we will say the bottom values, these two bottom values minus the two top ones, to get our respective delta y's and delta x's, which we will then use to calculate our distance, which is square root of delta y squared plus delta x squared. And then for the last part, we do our direction, which we calculate using arctan delta y over delta x. We look at our equation, we start with delta x. Because delta x is negative, we say plus 180, according to this rule. Now you will note that there's delta y, which is negative as well. You first look at x. If x is positive, then we only consider y. So yes, I know there's two separate rules for the two negatives, but x comes first. Only after the x do we look at y. You add that and you get your direction. Alright, so that is the last step, and this is how you would want to write it when you're doing the calculations. For my students, I will tell them this is how I want you to write the values. Alright, thank you very much. I hope this is quite a clear example, and have a good evening.